Hello everyone. Today my topic is about tributary sport dancing for elastic services with latency SLOs. And this topic belongs to the field of cloud computing. So, what's cloud computing? This is not a new field for now, and cloud computing has been developing for more than 10 years. In simple terms, cloud computing is a network that provides resources. Users can use it at any time according to their needs, and the resource can be regarded as infinitely expanded. They only need to pay for their usage to the provider of the resources. And a lot of companies have been working on this. In the United States, we have Google and Amazon. They are Amazon Web Services and Google Compute Engine to provide the service, and mainly the elastic service. And what's SLO? SLO means service level objective. SLO specifies a desired state of the functionality provided by the service. So it's an standard of service. And what are services with the SLOs? One is that time varying client workloads, which is handled with elastically sized resources. Another one is that how are they sized? It decides how many resources are needed, and add or release resources. Let's see the elastic service architecture. It has four components: load balancer, scaling policy, resources, and resource manager. At first, the user requests the resource from load balancer, and next, the load balancer forward the requests to resources, and at the same time, the load balancer forward requests to scaling policy, which demands how many resources the service needs in order to satisfy a given SLO. And finally, the resource manager add or remove the resources according to the result of scaling policy. Next, I will introduce two types of services in AWS EC2. One is called on-demand instances, which are non-preemptible acceleration, and the cost is higher than another type of service. This is an elastic service scaling scheme, which is a relatively safe assumption for high priority allocations in private clouds and non-preemptible allocations in public clouds. Another type of service is called spot instances, which are cheaper but offer preemptible resources. Preemptions often occur in bulk, and the bulk preemptions can cause traditional scaling schemes to have sizable gaps in SLO attainment. So we will focus on the spot instance and propose solution to preemption risks. Okay, so what's the problem of spot instance in AWS EC2? There are two problems. One is the likelihood of instance preemption is unreliable, and another one is the cost is not that low. And what are the reasons causing the problems? The author of this paper gives us 5 reasons. I just put them here and you can see them. And so this paper is to resolve these 2 problems, and it is called Tributary. Here we have the picture of Tributary's high-level system architecture. We can see that there are a lot of components in it, and I will introduce these components one by one and then introduce how they fit together and how they interact with AWS. The first component is called Acquire Manager. This is a core component in Tributary. Acquire Manager is a Tributary's resource acquisition component, and its approach differentiates Tributary from previous elastic control systems. Acquire Manager uses ML models to predict the preemption probability of resources and exploits the relative independence of AWS spot markets to account for potential bulk preemption by acquiring a diverse mix of preemptible resources collectively expect to satisfy the user-specified latency SLO. And this is preemption prediction models. The prediction models are trained offline using TensorFlow and deployed using TensorFlow serving. A separate model is used for each resource pool. To serve runtime prediction, Tributary launches a prediction serving proxy that receives all prediction queries from Acquire Manager, forwards them to their respective models, aggregates the result, and returns the prediction to Acquire Manager. The next component is a scaling policy. The scaling policy component demands dynamic sizing of the resource target through a simple event-driven API. Users can implement their own scaling policies that access metrics provided by the monitoring manager and specify the resource target. So next component is monitoring manager. The monitoring manager orchestrates monitoring of service system resources. The scaling policy can register for metrics such as total number of requests and average CPU utilization of instances. The monitoring manager queries requested metrics using AWS CloudWatch each monitoring period and forward them to the scaling policy. And the next component is called the resource manager. The resource manager is a proxy for acquire manager. Using resource targets provided by the scaling policy, the resource manager generates the utility function used by acquire manager to make resource acquisition decisions. The resource manager also receives instance allocations and termination notices from acquire manager and forward them to the service manager. So next, we talk about the evolution. We use three popular scaling policies to evaluate our system. The first one is reactive, and the second one is predictive moving window average, and the third one is predictive linear regression. So this is a result, and it shows the cost saving use our system. And this is detailed how much cost do we save. And here are the reasons for cost reduction with tributary. The first reason is that much of the reduction in cost compared to auto-scale is due to Tributary's ability to get free instance hours. Another reason is its ability to remove allocations that are not likely to be preempted when demand drops. When resource demand decreases, Tributary terminates instances that are least likely to be preempted, thus lowering the expected cost of its resource footprint. And it also compares Tributary and Pro tiers, and it shows Tributary is also the best. And this is a prediction model evolutions. Tributary improves prediction accuracy by using machine learning interface models trained with historical spot market data with engineered features. Finally, we do the conclusion. The Tributary exploits AWS spot instance to meet latency SLOs for elastic services at lower cost by predicting preemption probabilities and acquire diverse resource footprints. Tributary can aggressively use collections of cheap spot instances to reliably meet SLOs even in the face of backup preemptions. Our experiments shows cost saving of 81 to 86% relative to using a non-preemptible on-demand instance, and 47 to 62% relative to traditional high-risk use of spot instance. Okay, that's all. Thank you.